Hello, today we're going to talk about solving systems of equations by elimination. So this is also something that you talked about in Algebra 1. And the big idea that this whole thing hinges on is that if I have an equation where two things are equal, aren't I allowed to add equal amounts on both sides if I want to? Like if I have an equation, if I feel like adding 10 on the left and 10 on the right, is that okay? Like, will it maintain balance if I do that? Yes, that would be fine. What if I feel like adding, if you think of it like a weightlifting bar, what if I feel like adding 20 pounds on each side? Is that fine? Is it going to stay balanced? Yeah, that's going to stay balanced if I do that. As long as I add equal amounts on the two sides, we're good. What if I feel like adding 10 here and 5 plus 5 over here? Would that be okay? Like, I have a 10-pound weight for this side, and then over here I use two 5-pound plates. Will it still be equal in weight if I do that? 10 pounds here, 5 plus 5 over here. Yeah, that's fine. I can do that. That's still equal on both sides. So what I'm getting at there is sometimes if you add equal things, it might have a different look. As long as the two things are equal that you add, we're good. So that's like the big idea. So let's put that here. So here are your notes for the day. So go ahead and get your notes ready and start this. Solving systems by elimination is what we are doing here. And hinges on this idea. We can add equal amounts on both sides of an equation. So we got to follow that. Let's see what this is going to look like here. So let's say that we have this system. So I'm going to use two different colors again. So 7x plus 3y equals 19. 7x plus 3y equals 19. So there's one equation. And my second equation is going to be 3x minus 3y equals 31. Okay, so I have this system of equations, two equations. I want to see if I can find a solution or an xy pair that would satisfy both of them. Okay, if we were going to graph them, it would be on the blue line and the red line. It would be the purple point. But we are not going to graph them today. If I think about yesterday's method of substitution, this is not a super candidate as I examine it for substitution. Because do you remember what we mentioned as like qualifications that would make something an easy system to solve with substitution? We talked about having a variable by itself. Well, if I look at the blue x and the blue y, neither one of those variables is by itself. It doesn't say just x equals blah, 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 or y equals blah, blah, blah. And if I look at the red equation, which you cannot see, can you? 3x minus 3y equals 31 is what that was. If I look at that red equation, it also doesn't just say x equals blah, 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 or y equals blah, blah, blah. And none of these variables, the red x, red y, blue x, or blue y, would be super easy to get by itself. And by that I mean none of them have a coefficient of 1. So I could do it. I could solve this by substitution. I don't want to make you think you couldn't. It just would be awkward and hard, and I just would rather have another method, which we do. So anyway, we talked about that I could add equal amounts on the two sides, right? So I want to take this blue equation and I'm going to add equal amounts on the two sides. So as long as I put equal amounts in those two red boxes, it's going to be okay, right? So what if I felt like adding 31 on both sides of the two boxes? Is that okay? If I felt like adding 31 pounds on both sides, could I do that? As long as I did it on both sides, would that be fair? Well, what does 31 equal? If you look at that red equation, 31 is also equal to 3x minus 3y. So here's what I'm going to do. I'm going to add 3x minus 3y equals 31. Now look at those two red boxes. If I look at this equation over here, aren't those two things equal to each other? Don't they have the same value? Because my red equation has an equal sign between them. So I can add those on my blue equation because I'm adding equal quantities in those red boxes. So I'm going to add these together. So if I do this, I'm looking in my columns here, and it's going to be really important that you have everything nice and lined up when you go to do this. I have my equal signs lined up. My x's are over my x's, my y's are over my y's, my equal signs, my constants. That's the formatting you're going to want to check for. You might need to do some rearranging to get it there, but this one's already ready to go. Everything lines up with its like terms. So if I look in my columns here, I have 7x plus 3x. Well, that would give me 10x's when I put those together. So 10x. If I look at my y's, I have 3y minus 3y. And that's going to cancel out. 3y minus 3y, that goes away, so no more y's. And then if I look at my constants on the right there, I have 19 plus 31, because I'm adding what's in the red box there, and that would come out to be 50. So if you look at that black line, this equation is much easier now. It says 10x equals 50. Well, can you figure out what your x is from there? I want to get that x by itself. Right now that x is multiplied by 10. So we're going to have to divide by 10 on both sides. And when I do that, 10's cancel, so x equals 5. So that is halfway to our solution because now we know that x is 5. And we're looking for an ordered pair here, so I need to also figure out what y is. So at this point, we know that x equals 5. We can use that in either equation, so you can decide if you like the blue one better or the red one that we started with. And I don't know, I think I'll use the red one. So if I have 3x plus 3y equals 31, and I know that x equals 5, right here where the x is, I'm going to replace that x with a 5. So 3 times 5 is 15. So I have 15 minus 3y equals 31. And if I want to get that y by itself, I'm trying to figure out what y is here. So I'm going to subtract 15 on both sides. And those 15's cancel, so I have negative 3y equals, let's see, that would be 16. So I need to divide by negative 3, divide by negative 3 on both sides, the negatives and the 3's cancel. So y equals, so you can leave that improper, that's fine with me if you want to leave it as negative 16/3. We usually move the negative sign out front on that. Or if you want to think of it as a mixed number, you would be talking about negative 5 1/3 is what that would be. So either. You could say the decimal, but it's a repeating decimal, so I wouldn't. We prefer fractions as we move up into higher math. So I think I'll put the mixed number form right here, negative 5 1/3. So that's where those two lines would cross if we graph them. So what made this problem come out so nice? Let's go back up to, and by so nice, I mean this line right here, where we went from the blue equation, 7x plus 3y equals 19, and the red equation, 3x minus 3y equals 31. And when we put those together, we got 10x equals 50, which is much easier to deal with because there aren't any more y's. So how did that happen? Why did that occur? Well, it has to do with, we had a 3y and a minus 3y. So they went away. What do we call this method again? What am I teaching you about today or reminding you of since you already know about this? This is solving by elimination. So we eliminated the y's. The reason that happened is because we had matching coefficients just with opposite signs. So on that set of variables. So they canceled each other out. They went away. That's what you're looking for. If you want something to eliminate. You want to eliminate one of the variables. You want one of the variables to go away. so that you can just focus on the other one. So that is key if you're going to use elimination. So let's make a note about that. We want to have a variable set that has matching, oops, I know you can't see that, can you? Let me fix that. Oh no. Matching coefficients with opposite signs. Oh, let me make a note that we need to check that like terms line up. Make sure we check that like terms line up. Okay, so let's try another one here. So example 2. Let's do 5x plus 2y equals 43. And our second equation is negative 6x plus 3y equals negative 30. So first thing I'm going to look at is I want to see if my variables are all nice and lined up. X's over X's, Y's over Y's, equals over equals, constants over constants. We're good. Okay, so that's good. We just got to get that check out of the way. This is not one I would like to solve by substitution or by graphing because it wouldn't do nicely with either of those. We're going to try it with elimination. So we want one of our set of variables to eliminate. So check your X's. So cover up the Y's for a second. Just look at your X's. Are they going to eliminate if I would add these equations together right now? Well, they have different coefficients, so they won't. So that's not good. Look at your Y's. Are they going to eliminate? We have a 2y and a 3y. No, they wouldn't eliminate each other either. So that's a bummer. I don't have coefficients that are going to eliminate each other nicely on this. It's really unfortunate. I really wish that I had something that would like knock each other out. So I'm looking at the Y's right now. So you can choose which letter you would like to eliminate. I want to make the Y's go away. So I have a 2y in the first one and I have a 3y in the second one. And it's really unfortunate those don't have matching coefficients. I wonder if I could think of something to do to make those coefficients maybe both be 6's. If I had 6 y's in both of them, that would be really helpful if I had 6 y's. Can you think of how I'm getting a 6y as a target here? If I have equations, I'm allowed to multiply on both sides of an equation, right? Well, I could take that red equation there and I could multiply that whole red equation by a 3 on both sides. Is that legal if I feel like doing that? If I want to multiply both sides of that equation by 3? Well, sure, I can do that. So let me scroll so you can think. If I write small enough, you'll be able to see what I do here. So that would turn this equation. So I'm making a yields sign. It looks like an equal with an arrow attached. It means this is going to become something else. And I'm color coding on purpose so I can tell what equation is going where. One thing with systems is it can be hard to track your own thought process when you look back at these later. So I'm showing that I'm multiplying both sides by 3, and then I'm going to write it off to the side here. So I'm going to get 15x plus 6y equals, and that would be, let's see, 129 over there. I think you can see that next to my picture. My picture doesn't show to me when I'm recording, so I hope this is going to work. So now I was trying to get my y's to have matching coefficients here, and I mentioned 6 because 2 and 3 could both turn into a 6 through multiplication. So what could I multiply this blue equation by if I want my y here to be 6y's instead of 3y's? Well, 2. If I double everything, wouldn't that accomplish that goal? So keep your eye on the prize. I want to have matching coefficients on my y's. So I'm going to multiply by 2 on both sides of this equation and see what it becomes. So that's going to become a negative 12x and a plus 6y. And don't forget to multiply the right side of the equation by the 2 as well. That's a common mistake. So that negative 30 is also getting multiplied by 2, so that'll be a negative 60 over there. So we have a new system of equations. So look at your y. See how we have a red 6y and we have a blue 6y? If I add those together, are they going to cancel out? No, darn it. Because I have matching coefficients, but I really want one of them to be positive and one of them to be negative. I need to have opposite signs here so that they will cancel each other out. I don't want to make 12 y's. That's not what I'm trying to do. I'm trying to make those y's go away. So to fix that, I'm going to take my blue equation and multiply everything by a negative 1. All that's going to do is switch the signs in that equation. So I'm going to put that I'm multiplying by a negative 1 right here in blue so I remember what I'm doing. And that's going to make it turn to a plus 12y and a minus 6y and a plus 60. Okay, so I just changed all of the signs in that. Now, when I go to add these together, my 6y's, my plus 6y and my minus 6y is going to cancel out. That's what I'm going for when I'm using elimination. I want something to eliminate. So let's see what we would have left. So 15x's plus 12x's, that would be 27x's equals, and then over here that's going to be 189 when I add those together. So I need to get x by itself now, so I'm going to divide both sides by 27. 27's cancel here. Let's see. Oh my goodness, 189 divided by 27. 189 divided, oh here, I got a calculator. What am I doing? 189 divided by 27 is 7. There we go. Okay. X equals 7. All right, so we are halfway to our solution. Remember, solutions are ordered pairs. So I need an x and a y pair here. So I've got my x value, that's helpful, but I need my y value too. So let's see. We're going to take that x equals 7 and plug it into one of our equations. So I could use either original, the red one or the blue one. I think the red one looks easier. So I'm going to use that 5x plus 2y equals 43. So I'm going to copy that down here where I have some space. So it was 5x plus 2y equals 43. And I know that x equals 7. So I'm going to replace my x with the 7. I'm going to fill it in. So over here is where that's going to happen. My x is going to get replaced with a 7. So I'm going to have 5 times 7 plus 2y equals 43. 5 times 7, that gives me a 35. So 35 plus 2y. Darn light shuts off on me. 35 plus 2y equals 43. So I got to subtract 35 on both sides. So the 35's cancel. So 2y equals, let's see, what would that be? That is 8. So if we divide by 2, get y by itself, we get y equals 4. So y equals 4. So the ordered pair 7, 4 is my solution to this systems. To check that, take the x value of 7 and the y value of 4 and plug it into both of your original equations and make sure they come out true. Make sure that they work in there. And it does. It works in both of them. So that is how you solve by substitution. So I think that is everything that I need to tell you today. So you'll have some practice problems on this. And I know this is still like Algebra 1 level. Don't worry, we're getting to the Algebra 2 level of these soon. But I want to make sure that you understand or remember the concepts from Algebra 1 first. So remember that Jesus loves you and so do I, so do your math.